And we're back here in the studio. So nice that you join us here at the ARC CBBC Symposium. I've got two new guests to talk with here, standing with me. Robert Terorde from BASF, your Senior Research Manager Catalysis over there. And Lotte Metz from the University of Amsterdam, a PhD candidate, Fundamentals of Catalysis. Well, we are going to talk further about the video we just saw. Let's start with you, Robert. Then, why is this work, this catalysis work, so important? Has it to do with the reduction of the preventing of CO2 emissions?
Well, yes, partly. And so to talk a little bit about CO2, if you talk about CO2, you talk about greenhouse gases. Mm-hmm. I brought a graph about that where you can see this. I don't know whether that's going to be shown, but in such graphs you can see that since 1919, in this example, worldwide the greenhouse gas emissions have really gone up. We knew that, of course, and CO2 is one of those greenhouse gases. There's many more, even worse gases that do this, and we have to turn that around. So that's the big challenge. What you also see in this graph is a green line, and that actually shows that since 1990, as a chemical industry, and the example given here is for BASF, which is a large chemical company, the exhaust of the emission of greenhouse gases has actually gone down quite a bit already.
And that's a tremendous achievement because your production went up.
Exactly. Yeah, so this was indeed a big challenge. The bigger challenge is still to come, I should say that. I mean, challenges like emission-free in 2050, that's not easy, of course. Yeah. But I'm bringing this because the way to get from 1990 to here, catalysis has played a big role. So catalysts were really the things helping the conversion of these greenhouse gases and therefore bringing these whole emissions down. So a very important enabler for changing the chemistry. And that is already seen, actually, if you look at what we have accomplished.
Yeah. So catalyst plays a really important role. So it's important to understand it, and therefore, Lotte, you play a very important role. Because tell us, what are you doing? How does your research work? How does it work?
Well, the thing is, of course, the catalysts that Robert is talking about are nanoparticles. And my research...
Very small, very small particles.
Yeah, so if you have like the world is a meter, then probably a nanometer is an orange, so it's very small. And the thing with these things is, because they're very small, it's very hard to control their size when you make them. And well, how you can think of this actually maybe is with bubbles. Mm-hmm. So if you try to make bubbles, then you can't make two of them alike actually, because every time you blow air into it, maybe a little bit less. Yeah. But also, of course, how much soap is in there or the humidity. So all these things influence the size. But in the other hand, this also influences how they behave. So how much they levitate or how fast they will pop or like how they color. And this is also really important for nanoparticles and also the biggest challenge. And if we precisely know how we can control this, then we can make them better.
And you can make them work better because they are more alike, and the process you just described will work better.
Exactly. And the way I want to do this is by making a molecular mold. So I cannot just like mix everything together, but it's sort of...
What is it, a molecular mold?
It's very difficult. It's a tongue twister, yeah. But a molecular mold. So basically, I put the ingredients for the nanoparticles inside, let's say, a cage that I click together from molecules.
Just like you bake cookies, and then every one is exactly alike.
Yeah. So I make, maybe I make a molecular baking tray, if you say it like this. And then every time the particle will be the same. And then we also know that this property is linked to this size, and then we can find the best one. That's the goal.
Great. And then, Robert, of course, because well, what's then the benefit eventually? And I know already, because we talked about it in the previous part, it will take years and years, but what is eventually the benefit for consumers, for society?
Now, society, I think, from this won't see so much very different products. They will still have their mobile phones, they will have their cars, they will have their insulation on their houses. But the difference they are going to see is that these are now made in processes not emitting CO2 anymore, and maybe even products which are going to be used as new products after their end of life. So more circular, less linear, and that's really going to make a big difference.
That's also what Jörg just said, that we move towards circular production. That's really hard, I think, to do so, because you have to reinvent the whole production process.
Absolutely.
But this can help, this will help. basically you're saying this is an essential building block to do so.
Absolutely, and I would say, so whether you go from recycled plastics or whether you go from biomass, which you're going to use as a feedstock, for all these processes, catalysts are going to be needed, new catalysts are going to be developed, and this program is really about finding ways of doing that better, more precisely, and therefore we spend a lot of creative energy on this in this project in ArcCBBC.
Sounds really great, isn't it? Doesn't it, Lotte? What is your dream? How do you want to leave the planet for your eventually children and grandchildren? What are you working towards?
Well, I hope that these catalysts will actually, as Robert says, help in the circular economy and also to reduce CO2 and, let's say, have these particles make less waste, so actually, and use less resources. So if they are more selective, they use less and they make less waste and also cost less energy to make. And so my dream is that we can design and tailor these catalysts for these purposes, so we can improve the world on the macro scale by controlling it on the nano scale.
Wow, what a great! You should write this on a tile, you know, and spread around. Perfect. Thank you very much, Lotte Metz and Robert Terorde. Thank you very much for joining us here.